So 451 is a 2D sketch. We have a 3-inch diameter, 2-inch diameter through hole, so we can start with that geometry. And then part of this is going to be deciphering the notches and the holes. So this one looks straight through, to center line and then a 1/2 inch deeper. So nothing really challenging there. Over on the side, so this would project over to this line, and then these at the angles 0.8 up should be a 45 degree, but we'll use those dimensions. So this is a an inch part, and we'll draw this from the right side. And so 3 inches. And 2 inches for the ID, and overall length of 7 inches. Alright, so once again they show section views, but then we are not privy to those section views. So that being the case, let's see, our dimensions are all kind of off of the end. Yeah, maybe we'll do some planes for this one. So let's see, most of the dimensions, it's kind of a toss-up. It doesn't really matter. So 7 inches the side. Alright, so on the front plane then, we'll get into the corner rectangle. I'll look for that silhouette, or in that case coincident. And the width of our notch is 1.5. And the depth, oh, that went to center line, so not as critical. So to coincident. Off of the end then, that went 1.5 to the edge, so upper 1 inch. Okay, and then I was thinking I would put the notch in, but the notch still is at an angle on that one, so 1/2 inch deep, and it shows it at a little bit of a, is either going to pick up at an angle, but it doesn't look like the same angle, so that section A would be handy. So if I fly that back in, and this makes the cut pretty much through that face into the bottom side. Okay, so kind of seeing it. This bottom part of the cylinder is falling away, and then this is just the intersection. Okay, so that being the case, we're going to extrude cut through both, since we're in the middle of the part. On this segment then, we'll go to sketch, and I want to be enough farther that I don't have to worry about the section or leaving any of the radius there. So this is 1/2 inch wide, 1.5 inches, and 1/2 inch, so we could go with the center. So selecting the midpoint, control selecting the edge, make midpoint, and then we'll go to the center, coincident, and then that gets extrude cut 0.5. Alright, so that looks pretty good. Alright, the other geometry at the angle then, we have the choice of the from and to, but I think on this one I want to go with an offset plane. So from the right, hold down the control button, select the plane, and we're going to drag in the direction we want to go. We'll give it 2 inches for, nope, not 2 inches, 1.5 inches for its location, and then go ahead and accept it. Start our sketch. And we have started the geometry, so we have the line to depth on the notch, and then we're going to set for the angles. So I'm going to need at least part of that arc. So we'll convert that into yen. Line through the center. Double check, so we got a coincident. And coincident to the edges. And then we're given a dimension of 0.88 to the bottom side. Alright, and then if we wanted to just double check it, that will be a driven dimension, but it verifies that we're at the correct angle. And then if we stay with the contour and region, I can just pick the upper portion, and this will be 2 inches. The interior section, we have the cut. Then we'll hide the plane, go back into solid, and other than deciphering the 2D, that really wasn't as bad as I was expecting it to be. So P451. Okay, so we'll go ahead and close that and jump over to the next 2D sketch. Alright, so partial revolve. This notch has the issue with the radiuses. Let's see, drill point to the end. Pretty much just intersection on the notches. So I guess wherever we can find those diameters, 30, 60, and then the lengths of 150. All right, so pretty much going to generate the one profile. We'll close this completely off, and so that'll drive some of our decisions. Part metric, and I reduced that when I needed to fly it out. Front plane, center line, horizontal infinite length. Alright, so I have the line to close everything, up, over, back, down, and around. Go ahead and include the chamfer, and missed by just a little bit. Okay, and then those can go to merge or coincident. So overall is 200 millimeters, and outside diameter is 60. So missed that one by just a little bit. 40 to the next step. Go ahead and bring that back, and we'll set the dimension. And let's see, are we given a height? I don't say anything that says 5 millimeters, but that is going to be the guess until we get something different. Alright, 50 millimeters on the end, 100 millimeters, and 30 millimeters at the end geometry. Okay, so that should be enough to create the revolve. So we'll take a look at our notches. So looking at this from the front, we have 40, and that depth is listed to 20 deep. So that'll be part of the, eventually that'll be part of the cut. So that being the case, go into the front plane. And we do have the 2 notches, so we'll put those together. Alright, so finding coincidence, and then up and over. Alright, so lower is given as 14, distance of 60, and 10 millimeters back from the face. Top then is given as 40, 20 millimeters back from the end of the conical face, and that depth is part of the continuation of the slot. So the slot is given as 20 by 30 deep. And so let's see. Oh, no, sorry, that's the drilled hole. We have a dimension that says we're 20 off of the center line, so we'll go 10 on the face. So if we needed to, pull the 20 out, whichever one's more convenient there. Alright, so extrude cut through both directions. Go into the to the top. Find our notch. And we'll set midpoints. Collinear, coincident. Width of the notch then is, well, if those are the same, we'll be at 20 millimeters. Okay. And the rear notch is just a little bit deeper. So extrude cut. We're going to reverse the direction, go through all, and make the cut. Alright, so that looks pretty good on that side. Have the hole going through, and let's go ahead and stay with the notches. So that being the case, we'll go to the top plane, and we're going to stay with the simple planes. Kind of quick, easy to make is select the plane, control select the envelope of the plane, drag out, and then set a distance. And so this is set pretty much parallel at parallel by default, but 10 millimeters off of the selected plane. And then we can go in and open a sketch. Go to our end distance. Let's go select midpoint, and even though that is a circular face, it is projected into our sketch plane as a line, so we have a midpoint. And design intent, I want this width to match that width, so those can be collinear. And then our overall distance, let's go back normal 2 just to make selecting a little easier. Our normal distance will be 25 millimeters. Features, extrude cut, and we'll reverse the direction through all. Okay, so the issue here is going to be that these corners being square, we're going to have to again have a special manufacturing process. So that being 20 millimeters, even if I put a 6 millimeter radius in there, so we could use, let's see, 6.35 would be a 1/4 inch tool. If I put 6 millimeters in there, I could use a 3/8 inch diameter tool, close to 10 millimeters, and put enough of a radius, as long as I have the relief there to work with. So we'll go with that for now, and then I forgot the hole in the center, so we'll open a sketch on the face. And center is 40 back, so I'll make sure that I got a horizontal relation. (40 millimeters) and 30 millimeters in diameter. Features, extrude cut through all, and that should complete the geometry. We roll forward on the fillet, hide the plane, and let's go ahead and save it, and then we'll compare it to our geometry. So P4-52. Alright, looking at this in wireframe then. I'm not going to have too much room, so I did miss one. We have the hole to drill in the end, but other than that, have pretty much the same wireframe. Alright, so 20 millimeter, this one we're going to have the drill point, so I'm going to go to Hole Wizard, slip back into solid, make sure we're in a simple or standard hole, ANSI metric, drill size. I'm going to scroll down a little ways, to 20 millimeters. Depth is 30 millimeters to the shoulder. And position is center of the face. And we'll go ahead and accept. Alright, so one more check. We look at the wireframe. We have the depth. And maybe they used a 135 degree drill point for a little bit of a change in the angle. And let's see on the top. Yeah, pretty much have our geometry in. Okay. So we'll go ahead and save. Close that out. Alright, projections. Equilateral, triangle. Alright, so I haven't really looked at these to figure out what we're trying to do. Have a 15 degree angle, 50 millimeter diameter, 62 degree tall. So we'll go with that one first, and then we're going to pick up a projection line. Triangle, 31 up off of the base, 86 out. Okay, so kind of working from those numbers, looking at what it's going to be, what it's going to take for the intersection. Top plane, sketch, circle, 50 millimeters. And we'll go ahead and extrude that. Make sure to select the sketch. 62. Shouldn't really need to have the selected contours for this one. Alright, right plane. I'm going to bring another plane out. And that one's going to be the 86 millimeter. That looks a lot longer than theirs, or a lot wider anyway. Right plane, and we'll go to 43 millimeters. So about half. So it makes me wonder, based on the drawing, some of the other issues we've had, that if this wasn't 86 overall and 43 was the half dimension. I'm more inclined to believe that. So again, making a design decision kind of based on, well, hopefully some logic. Oh, and since I hit the save, let's go ahead and put this in, 457. And now I need a sketch to get this started. Equilateral triangle, 30 per side. Alright, so 31 to the center mark, so they are going to take that through mid. Alright, so bring this back over, center line, 31 on a 62 millimeter height. So that'll be the intersection of our plane, so I'm back into the front plane. We'll generate a center line from origin up. And then from plane to plane, we'll select the midpoint, and that can be midpoint, I guess it needs to be, well, we'll make it coincident just in case the 86 millimeters doesn't pan out. Alright, so smart dimension, endpoint, line, direction of the arrow, 15 degrees. So that gives us our location, and still wouldn't swear the equilateral triangle is exactly centered on that face, but we're going to go with it. Alright, so opening up the sketch, we're going to go into the to the polygon. Let's see if we go 3 sides. Don't really have a number, so I'll look for that endpoint. Pull the geometry off. 30 millimeters. That's a little bit bigger. We will go to a horizontal line. Alright, and they're showing the end faces as being parallel to those, to the right plane, so that's what I'm going to go with. Features, extrude, and we're going in the direction of the line, reversing the direction. And if we go up to vertex, that would be the end point of the line, and it stays normal too. Or we could go up to surface and use the plane. Alright, so both of those are workable. So going to 3, left, right. Yeah, doesn't quite pick up the projection, the intersection, but that looks pretty well close. So plane 1 and plane 2 we can hide, and sketch 2 we're through with and can hide, and that generates the geometry. Okay, one more save. I'll fly over, see what 458 looks like. So rectangle through a cylinder, or square through a cylinder. That one should be along the same lines. Cylinder through a cylinder. And these are both in metric. So maybe we'll do those as solid bodies, just to. No, we'll go ahead. Making it too complicated. So top cylinder, or go into the circle to generate our cylinder. Have a diameter of 30. Going to extrude out 28 plus 41. Right plane, open up the sketch. We'll go with the center rectangle, roughly position it over the origin. So that sets our midpoint. We'll define it by vertical. Have our 28 millimeters. And now the 41 was pretty much there. 36 and 36 was there. So that'll give us the out. And we'll set the sides equal. Extrude boss, we have an overall. We're going to midplane, 72 millimeters, 36 each side. And there's my model. I'll save it. And that one is 4-58.